welcome back to my YouTube channel. Again, it's me, Mabel. For today's video, we're having some learning again about another topics of mathematics, and let's get started. Let's get started for this tutorial, and this is our lesson now, the application of first order differential equations. And there are three applications of first order differential equation. The first one is the Newton's law of cooling, and the second one is laws of growth and decay, and the third one is the orthogonal trajectories. But for this tutorial, we will focusing the two application, which is the Newton's law of cooling and laws of growth and decay. So let's move forward to the next page, which is the Newton's law of cooling. Newton's law of cooling is the rate at which a body cools is proportional to the difference between the temperature of the body and that of the medium. And there are rate equation and general solution. The rate equation is d over t is directly proportional to t minus t sub m is equal to dt, which is the big T, over the dt or the time, is equal to k times t minus t sub m. This is our rate equation, and through the rate equation we formulate the general solution, which is the t is equal to t sub m plus c times e raised to kt. So where the big T is for the temperature of substance or the body, and the small letter t is for the time, and the k is for the proportionality constant, and the t sub m is for the temperature of the medium. Now to use the general solution, this is the solution now. A thermometer is taken from an inside room to the outside, where the air temperature is 5 degrees Fahrenheit. After 1 minute, the thermometer reads 55 degrees Fahrenheit, and after 5 minutes, it reads 30 degrees Fahrenheit. What was the initial temperature of the thermometer when inside the room? The first one, we will going to determine the temperature after 1 minute. The thermometer reads the 55 degrees Fahrenheit. And the second one is the after 5 minutes is read to 30 degrees Fahrenheit. So let's have the solution now. We use the general solution, which is the t is equal to t sub m plus c times e raised to kt. So let's t or our time is 0 and the t is the unknown, and the t sub m, which is the 5 degree Fahrenheit. So let's substitute to the general solution. Our t, copy the t, and is equal to t sub m is equal to 5 plus c e raised to k times 0. So t is equal to 5 plus c. So now let's get the equation 1. So our t now is the 1 minute, and our t is equal to 55 degree Fahrenheit. So we use the solution, the general solution. So the t is 55 is equal to 5 plus c times e raised to k times 1. So 55 is equal to 5 plus c times e raised to k, and 50 minus 5 is equal to c times e raised to k. So the result now is 50 is equal to c times e k, as this is our equation 1. So let's move forward for the equation 2. So let our time is 5 minutes, and our t is equal to 30 degree Fahrenheit. So 30 is equal to 5 plus c times e raised to k times 5, which is our time. So 30 is equal to 5 plus c times e raised to 5k. So 30 minus 5 is equal to c times e raised to 5k. So 25 is equal to c e raised to 5k. So this is our equation 2 now. So from equation 1, 50 is equal to c times e raised to k. So, and let's substitute to equation 2, which is the c is equal to 50 rather over the e raised to k. So 25 is equal to quantity of 50 over e raised to k times e raised to 5k. 25 is equals to 50 quantity of e raised to 5k over e raised to k. So 25 is equal to 50 e raised to 4k. So let's divide that 50 both sides. So this is the result. 25 over 50 is equal to e raised to 4k. So 25 over 50, this is 1/2, is equal to e raised to 4k. So ln 1/2 is equal to ln e raised to 4k. So this is cancelled, and the remaining one is the ln times 1/2 is equal to 4k. So this is the value of k. K is equal to ln 1/2 over 4. Let's calculate it to the calculator. This is the result. This is equal to negative 0.173287. So we have our value of k now. So let's move forward for the solving to c. The value of c is equals to 50 over e raised to negative 0.173287. So we calculate to the calculator. This is c is equal to 59.46. So we have our value of c. Now this is the final one. So the t is equal to 5 plus c, because we have our value of c now, which is the 59.46. So t is equal to 5 plus 59.46. So this is equal to our t now here, or the final answer is 64.46 Fahrenheit. So this is the final answer. And now let's move forward for the second application, which is the laws of growth and decay. This is the rate at which the substances changes is the proportional to the quantity of substance present at any time. And this is the rate equation. The dx over dt is equal to k times x. And we formulate the general solution, which is the x is equal to c times e raised to kt, where the x is quantity of the substance present at any time, and the small letter t as for the time, and the k is the proportionality of the constant. To further understand the flow of growth and decay, so we have some example here. This is the example. The population of the town grows at the rate proportional to the population present at any time t. The initial population of 500 increases by 15% in 10 years. What will be the population in 30 years now? So let's get the solution. This is the solution now. So our x is equal to 500 and our time is equal to 0. So we use the general solution, which is x is equal to c times e raised to kt. We substitute the value. So our x is 500 is equal to c times e raised to k times 0. We cancel out. So the remaining one is the c is equal to 500. So let t, or our time, 10 years, and the our x is equal to 500 plus the 15%, or the 0 times 0.15 times 500, which is the x, is equal to 575. So now let's substitute to the general solution. So our x now is 575 is equal to 500, which is, and c times e raised to kt. So we divided both sides 500, so this is the result. The 575 over 500 is equal to c times e raised to 10k. So we have this result. The ln times 575 over 500 is equal to ln times e raised to 10k. So we have the k now. K is equals to, we calculate this one. This is the result. The 1 over 10 ln times 575 over 500. So let's move forward here. So our x now is 500 e raised to 1 over 10 ln times 575 over 500 times t, or the time. So x is equal to 500 e raised to t. Why t here? Because 1 times t is, well, t over 10 ln times 575 over 500. So okay, so let our time now is 30 years and our x still remaining unknown. X is equal to 500 e raised to 80 over 10 ln times 575 over 500 is equal to 760.44. Because we talk about population, this is converting to 760 people. So this is the answer. That's it for this video tutorial. I hope you learned something, and thank you so much for watching. Please don't forget to like and subscribe for this video, and have a good day everyone. God bless, and see you to the next videos.